Hi everyone. Today we at KeepFlying will present our FinTwin SkyBot Aviation Asset Analyzer as part of the Databricks Hackathon. Within the aviation industry, the management of an asset's documentation directly impacts its evaluation. Assets without documents have no value. The management of documentation is very time and labor intensive due to the size of each document, which generally spans a couple hundred pages. Most of the industry still uses hard copies, and approximately 60% of these documents are in an unusable format. The solution to this issue is to leverage an LLM tuned to the aviation domain to provide an interface through which a user can interact with documents without having to read the entire content. Firstly, we use an OCR to help us extract the data from the soft copies and store into databases. Secondly, the user will then interact with the LLM to answer queries related to the asset. The reduced time and cost for interpretation of asset data facilitates smarter commercial decision making.
Let's check out the SkyBot's architectural design. SkyBot interacts with the user using a chat interface. User uploads the asset-specific document and can query SkyBot to provide required analytics. The uploaded document is then pushed to the blob store and a SAS URL is created, which is passed as input to the agent, which contains OCR capabilities to extract the information from PDF. The agent can also trigger analytical tools required to provide asset analysis based on the user query. Post-processing is done on the agent output to provide a clean response to the user. The output of the agent is constantly monitored by the monitoring tools to ensure that the hallucinations are under control and the LLMs are not generating any harmful content. The tools used to build SkyBot. For fine-tuning of word embeddings in LLMs, we require a lot of data from multiple sources. We used Databricks structured streaming to ingest the data from different sources for fine-tuning. For embeddings, we used the Hugging Face sentence embeddings and fine-tuned on aviation-specific data. For retrieval augmentation generation tool, we used Facebook similarity search and FAISS vector store. We are currently using LoRa method to fine-tune the Llama 7 model for aviation-specific LLMs, which is in progress. Use the LangChain with OpenAI GPT 3.5 Turbo as LLM for prompt engineering and agent creation. For structuring the prompts, we used Microsoft Prompt Flow. LangSmith library was used to monitor and traceability of the agent's output to make sure that the generations are in control. Finally, we used Streamlit chat interface as our front-end view.
Now let's see a quick demo of our application. So SkyBot helps with documents related to an aircraft asset, such as an aircraft engine. So let's consider an engine mini pack, which is a document that contains details of an engine's operational history and other inspection records. Let's first upload the engine mini pack that we are interested in. And we also input the engine serial number. And once the document is ready, we can interact with it by prompting SkyBot to answer questions, extract information, or perform other computations. Let's begin with a simple question such as extracting the basic details of the engine. And now it uses the engine processor to extract the serial number and the TSR and CSR values of the engine, which are the time and cycle since the last repair. And if we go back to the PDF, we see that it has taken this information from the first page of the document, which has the engine serial number, as well as the time and cycle since the last shop visit, which refers to the last repair. We can also ask it to perform other computations such as forecasting the next shop visit for the engine, which is the number of cycles until the engine goes for the next maintenance or repair. Now it uses the LLP processor to get the operated cycles for each life-limited part in the engine, and then it passes on these values as inputs to the shop visit forecaster, which computes the forecast for the next 5 shop visits, with the first shop visit expected to occur after 9,000 cycles, and with the total cost of the repair estimated to be $36,000, which is indeed a rough estimate for the demonstration purposes, with the real costs being much higher. Apart from these, we can also ask other generic questions about the document, such as was the engine involved in any incident or accident? And now it uses the knowledge base to generate an answer saying that the engine has not been involved in such events, which, if we go back to the PDF again, has been taken from the non-incident statement section, which confirms that the equipment has not been involved in any serious incident or accidents. This shows how SkyBot can help perform a complete analysis of an engine or other aircraft assets.
The need for monitoring and debugging the model becomes very essential towards building a responsible AI. This will help to reduce the unpredictable behavior of these models. So here we specifically use LangSmith, a sophisticated tracing and monitoring tool. As you can see, all our calls to the LLM, agents and tools are traced here with input and output. If you go to Monitor tab, you can see a graphical representation of trace count with success and error rates, latency for each of the LLM calls, along with the number of tokens. All these informations are helpful to build a LLM that produces more responsible output. First and obvious future work is leveraging aviation data for fine-tuning LLMs that produces specific and relevant outcomes uniquely suited to this domain. We have already started the fine-tuning using a parameter evaluation method called LoRa. A feedback loop to accept the input from SME and thus continually enhance model performance while democratizing large language models in aviation through responsible AI practices is another key future goal. Another requirement in this domain is to make the model capable of generating more financial related outputs required in aviation industry. We are also planning to achieve richer context-specific outputs by connecting multiple data sources to agents. This will enhance the capacity of agents to generate more nuanced and context-specific insights. Thank you.